Okay, here's your study guide video for 11.5. This starts trigonometry, very important. The main idea is that trigonometric ratios are about relationships between the side lengths of right triangles. So this is just going to be right triangle trigonometry, just with right triangles. 2, organizing information. Name the 3 basic trigonometric ratios. You have sine, cosine, and tangent. On your calculator, it's these 3 buttons. Maybe you've always wondered what they would do. Okay, summarizing and using visual cues, use the triangle below to fill in the blanks. Okay, so here we have our angle. And you can choose either angle. I could choose this one, or I could choose this one. You can't choose the 90 though, okay? So you choose one of the acute angles, and then you decide what side is what. So the hypotenuse is always the hypotenuse. The opposite is what is ever opposite of the angle. So in this case, it would be this side. And then the adjacent means next to, and that's the side that's next to the angle. So there's 2 sides next to this angle. There's this side, and there's this side, but this one's already the hypotenuse. So that one is the adjacent. So it says the sine of an angle is the ratio of the length of the leg opposite that angle to the length of the hypotenuse So the sine of an angle is the length of the opposite divided by the length of the hypotenuse, and we'll explain that more later. Practicing visual cues. Use the triangle below to fill in the blanks. Okay, so that's sine. Okay, so we did sine. Now we got to do cosine. So the cosine of an angle is the ratio of the leg adjacent, that angle to the length of the hypotenuse, so that would be the adjacent divided by the hypotenuse, and again we'll explain that more later, and there's an easy way to memorize this that I'll tell you in a moment. 5. The tangent of an angle is the ratio of the opposite to the adjacent. So this one is opposite over adjacent. How do the letters SOHCAHTOA help you remember the trigonometric ratios? That's the next question there. So the way we remember this is SOHCAHTOA. The sine is the opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So you could just make a little arrow over there. 7, complete the table. Okay, so the sine of 30 is 1/2. Okay, and so you got 30, okay, 45, and 60. Okay, there's probably a better way to explain this, but I'll try to roll with it for you. So what this is saying is that you have a triangle. Remember the special triangles we learned last time, where we had a 90, a 30, and a 60. And this is saying that the sine of 30 is 1/2. So if you enter into your calculator sine 30, it's going to give you 1/2. So think about what the sine is. Sine is this, the opposite over the hypotenuse. So remember, the length of the short leg is half the length of the hypotenuse. So sine of 30, sine is opposite over hypotenuse, so here's 30. What's opposite? 1. What's hypotenuse? 2. So that's why it's 1 over 2. Okay. All right, let's do now the cosine of 30. Okay, so cosine is adjacent over hypotenuse. So if this is a half, 1 and 2, do you remember what the long leg of a 30, 60, 90 is? Well, it would be the square root of 3 times the short leg, which is 1 in this case. So it would be the square root of 3. So cosine is adjacent over hypotenuse. So I look at my little 30-degree angle, I'm like, okay, adjacent. What's adjacent to the 30-degree angle? Well, we talked about how adjacent means next to. So there's two things that are next to the 30-degree angle. There's the 2, and then there's the square root of 3. But 2 is already the hypotenuse, so the square root of 3 has to be the adjacent, and the hypotenuse is 2. Okay, and then the tangent of 30 is done for you. So tangent is opposite over adjacent. So what's opposite my 30-degree angle? What's across from it? 1 over the adjacent, which we determined is the square root of 3. Okay, now I talked a little bit in my last video, and hopefully they've taught you more about this, about how you can't have a square root as a denominator. And it's real easy to get rid of. All you have to do is multiply the top and the bottom of the fraction by the denominator. So 1 times the square root of 3 is the square root of 3, and the square root of 3 times the square root of 3 is 3. And now we're done with the 30, 60, 90. Let's see if I can explain. Well, actually, before we do the 45, let's do the 60, because we have the 60 already drawn in my picture here. But now we're looking at it from this, the 60-degree angle, okay? So my opposite changes, because what's opposite of 60 now? It's the square root of 3, right? What's across from 60 is the square root of 3. So let's do the sine of 60. What's opposite 60? Square root of 3 over the hypotenuse, which is 2. And that's how we got that. Now the cosine of 60. So I look up here, cosine is adjacent over hypotenuse. What's adjacent to my 60-degree angle? 1. And what's the hypotenuse? 2. Tangent of 60 is the opposite over the adjacent. So what's opposite 60 again? It's the square root of 3. And what's the adjacent? It's 1. So now we've done the 30 and the 60. Now let's do the 45-degree angle. So now I'm going to draw a triangle for you. That has that is a right triangle, because remember they're all right triangles in this. And it has a 45-degree angle, which of course means it has another 45-degree angle. So it doesn't matter which 45-degree angle we look at it from, because it's going to be the same. So if you remember from the last unit, it's 1, 1, and the square root of 2. So the sine of 45, what's opposite one of the 45-degree angles? The number 1 over the hypotenuse, which is the square root of 2. Hopefully you notice that we can't have the square root in the denominator, so we multiply it out. And that equals the square root of 2. And the square root of 2 times the square root of 2 is just 2. Cosine's done for you, but let's talk through it. That would be adjacent over hypotenuse. So what's adjacent to this? 1 over the hypotenuse. It's the same thing. Tangent. What's opposite the 45-degree angle? 1. And what's adjacent? 1. 1. 1. Okay. All right, the car problem. What do you want to know? You want to know how long the cable must be to reach the top of the mountain. Okay, it must be this picture down here. Okay, it's this picture right here, okay? So what do I know? I know the top of the mountain is 800 yards up. And the car must rise at what angle? I don't know if this was given to you guys somewhere else, but I can give it to you now. It's 37 degrees. And the problem is about finding the length of the, well, we need x. So what's x of this triangle? It's the hypotenuse. I will use the blank ratios to find the length. Okay. I will use the trig ratios to find the length. Okay. So they walk you through a bunch of steps here, but I will just help you with this. So first of all, you have to think about what angle you're going to use with trigonometry. So we can't use the 90. So we can use this one, or we can use this one. Either one will get you the right answer. I'm going to use 37 just because we already flat out just know it, okay? So look at that 37-degree angle. Which sides do we know? We know this, and we need this. So what are those from the 37-degree angle? Are they the opposite? Are they the adjacent? Or are they the hypotenuse? Well, the hypotenuse is x, and the opposite is 800, and the adjacent doesn't really come into it at all because it's this unmarked length here. So I don't even need to worry about that. So I have the opposite, and this problem involves the opposite and the hypotenuse. So which one of the trig functions, sine, cosine, or tangent, involves the opposite and the hypotenuse? So that means sine. So here's how you set up these problems. And that's all this is talking about down here, but I'll talk you through it. So the sine of 37 is going to be equal to the opposite, which is 800, over x. And now this is something that we are able to solve with cross multiplication. So just a quick review of cross multiplication. Remember, if we have something like this, I'll make that an easier number. Let's see, I'll make this 24. You can cross multiply, so remember we go 6 times 2, and we get 12, and that has to be equal to 24 times x. And then you divide both sides by 24, and you've solved the problem. It's no different here, it just looks more complicated. So you have to cross multiply and solve for x. So 1 times 800 is 800, and sine 37 times x is sine 37 times x. All right, now this is going to look a little weird, but it's okay. So now we have to solve for x, okay? So in order to do that, we need to divide both sides by sine 37, which looks weird, but your calculator will do it, okay? And when you do that, these cancel out, and x is equal to 800 divided by sine 37. So when you do that, you get, looks like they don't tell you here, but when you do that, you get 1,329. Which makes sense. If this was 800, the hypotenuse, that would make sense. Has to be longer, 1,329. Check it with your calculator right now. Go 800 divided by sine 37. Make sure you get 1,329. If you don't, your calculator is in radian mode. It needs to be in degree mode. So you might have to Google how to get your calculator in degree mode to get the answers, and then leave it in that for this entire unit. Okay, and then this was just the answer of 1,329. And hopefully that's helpful with